So RTE is the French transmission system operator. And I'm going to say a few words about Paul and Sabera. So Sabera has been working at RTE for 11 years now. She has spent the majority of her career on innovation projects with a focus on the development of electrical substation automation. And for the past 6 months, she's been coordinating a project called Planétaire, funded by the French government in energy system, in the energy sector, collaborating with the French industry and research players. So the project is centered around Antares, the energy system modeling tool for multi-energy, long-term adequacy and expansion planning studies. And now for Paul. Paul is a research manager at the R&D of RTE. He is responsible for the long-term adequacy modeling roadmap, which allows RTE to perform long-term studies to bring light on the coming energy transition and future landscapes, just like the Energy Pathway to 2050 prospective study. And Paul is more specifically involved in the modeling of multi-energy systems for planning studies on the implementation of a holistic view on energy systems and the associated flexibility needs and opportunities, and lastly on new tools and methods to efficiently simulate and optimize large-scale systems. So thank you to both of you, and we will have some time for questions after that.
So we didn't know that the screen will be so big, so you can't miss our picture. Boris Dole, who is the open source director, couldn't be here, so we will speak on his behalf. So thank you very much for giving us the opportunity to share about our open source strategy at RTE. So the first question which comes to mind is RTE an IT company? And the answer is no, because RTE is an operator of an infrastructure with 100,000 kilometers of line, for example, and almost 3,000 substations. So RTE, the French transmission system operator, is the biggest transmission system operator in Europe. But if we go into details, you can see that in our main activities, there are a lot of computers, as you can see here, here, and here again. And even for this kind of piece of paper, you need a computer to get it. So in all our activities, there are a lot of application software. And if you consider the 2 billion euros investment in 2023, you can see that 400 billion euros are dedicated to backbone, digital backbone and IT applications. And we have now almost 500 software solutions to monitor, to optimize, to operate our grid, and to achieve the energy transition. So what kind of solution do we need to face the energy transition? We need something modular, because we don't know our needs. Our needs are moving. So we need the ability to remove and add a feature. We need something interoperable. It means that we don't want to be locked with a vendor, for example, with a specific protocol. We need something standardized. We need customizable modules, because there is specific requirements in RTE, for example, for cybersecurity. We need scalable modules. It means that we have to make the transition between a proof of concept, or R&D prototype, for example, to something scalable to our 3,000 substations, for example. We need transparency, because we want the trust in our studies, and we want to collaborate with research institutes. And if you are French, we are paid by your taxes. So we need to be resource efficient and focus our developers on the high-value activities, not to reinvent the wheel. So if you consider all these criteria, open source is obviously a key to innovate. But it's not only a key, it's a game changer. And I will give you an example. Yesterday, not so long ago, but okay. Yesterday, we used to buying black box solution for our entire control system in the substation from one single vendor. So when there was an incident on the substation, for example, we were not able to understand what happened there. And now, what we are promoting now is to have an open source platform, a real-time platform, in which we can host all the algorithm codes for protection and automation of our grid. And it changes the relation with our suppliers, because our suppliers become now a service provider. They can provide us code or also an integration services. So all the 500 applications I mentioned before are open source. We have already 10 applications open source, but it covers all the layers of our activities, and this is the interesting point, from the operational activities, from the substation to the control center. We have also grid simulation tools, such as from the transient regime study to the steady state study. We have also forecasting and prospective activities, tools for prospective activities, such as open short-term energy forecasting, or also the entire simulator, and we will focus on it in a bit later. So what about the other applications that are not open source? In fact, in several domains, in many domains, the open source applications are not mature, or they were not mature enough when we developed our solutions. And sometimes applications are very specific to RTE activities, so it's not profitable to make it open source. And most of the time, we have limited resources. And the process to make an application open source is very demanding. You have to document it, you have to make a governance. So this is the constraint.
We change speaker from time to time to keep you a bit awakened. Lunch is close. So now we are going to talk about maybe our specificities at RTE on our strategies to promote open source and to promote our ecosystem of partnerships. So basically, in our strategy, there are 4 main axes that we would like to put a bit of emphasis on. The first one is the reliance of open source structures and associations, like the Linux Foundation for Energy. The second one is the collaboration with the whole ecosystem of partners of many different profiles. The third one is the internal promotion of open source, which is not something so obvious in a big company. And the fourth one is the participation to existing learned societies and to existing standardization structures. So starting with the reliance on open source structures. So first of all, well, it was mentioned already in a few presentations, so I guess that you guys are pretty knowledgeable with the Linux Foundation for Energy. But RTE participated in building the Linux Foundation of Energy back in 2017, and we are proud to be a strategic member of the LFE. So basically, the LFE is a non-profit organization which goal is to bring together all type of actors, industrial actors, utilities, research associations, vendors, etc., within open source projects. So it's vendor neutral. It has a neutral governance, and it provides a hosting infrastructure and the project management infrastructure as well as support in communication and promotion of projects, basically. So we put some euros here, or some dollars. People can join the Linux Foundation for Energy in the governance board, but of course, everybody can participate freely to any Linux Foundation for project, basically, because the governance for the project is different from the governance from the LFE board. So feel free to participate to all of this project, of course. And on this existing association, I'd like to mention CRESIM as well. It was already presented by Sébastien yesterday. But we, let's say, participate into European research association like CRESIM in order to develop research and methodologies which are maybe of a lower maturity level, but which make open source a core value, because we think that even when we are not talking about developing IT applications, but also developing new methods and research, it's important to have open source as a key driver. Regarding the ecosystem of partnerships, from years now at the R&D level, we have partnerships with a lot of partners. We put a lot of acronyms here to impress you a bit. But no, let's say that we have partners at national, European, and international level. Sorry. And just like for the Linux Foundation of Energy, we partner with big industrials, with small startups, with research associations, with other utilities, etc., etc. So we really try to gather different partners from different worlds, because we think that as a transmission system operator, we are at the center of a lot of domains, and of course we don't pretend that we have all the knowledge to do what we do, especially in prospective studies, which is a topic that I know a bit more. So we need basically expertise from the outside world. And I'll come back to that, but in order to enhance this collaboration with partners, we are also involved in some projects within CRESIM, of course, but also other projects like the Planetaire project that Sabera is coordinating. We'll talk a bit about that later. And on our open source applications that we release, to give you an example, we use weak copyleft licenses like MPL or Apache, to increase collaboration and to encourage collaboration on our solutions. So I let you the floor, Sabera.
So Paul explained you our strategy with the external partners. But to promote open source in a big company, as RTE is, you have also to promote open source best practices internally. And we have two approaches. The first one is to create developer teams. So we have now 140 developers to promote open source ambition. And we have also an OSPO. OSPO, it's the established term to say an open source program office to implement the best practices. But I will take a moment just to share you the second approach, which is a little less common. It is called the internal open source. And what does it mean? It means to get from the best practices of open source, but internally for the modules shared between several entities of the same company. So, for example, we encourage in our company now to share common libraries, common modules, and also to implement our solution in a microservices architecture, because it's very important to share also inside the company. And we have an example of a successful project, which is now open source totally. It's possible, and we are used to saying that we save the work of 50 developers for 1 year by mutualizing the modules in several applications. And the second point is the Dev Studio. Dev Studio is the belief that everyone is a developer in the making. And every employee can contribute, can share their code, and can be supported in their development skills. So we have a GitHub, a beautiful GitHub, to share the code of all the employees. And the last point, but not least, is to participate in a learned society and to promote standardization over the long term. We think it's a mandatory path for energy transition to work on the standardization.
Thank you. So now that we have presented the global strategy at RTE on open source, we'd like to focus on two projects that we've been working on, which can be good illustration or way on increasing maturity on open source and also on what is left on our side to be done. I'd like to focus first on the tool on which I personally work, which is called Antares Simulator. So just to give you a quick overview, but I guess from the presentation we had that most of you are familiar with this kind of approach. Antares Simulator is a tool which allows to model a system, a multi-energy system, to simulate its behavior and to perform investment planning on this system. And maybe a specificity compared to other models is that in order to do so, we rely on a partially stochastic approach because, for example, when we want to perform a study at the 2030 horizon, we will simulate a lot of scenarios of what can be the weather at 2030, of what can be the availability of the thermal units, of what can be the availability of the network as well. And this is what we call Monte Carlo years, which are like possible scenarios of what can happen in 2030 for a given energy mix. And using that, we perform analysis to simulate the behavior of our system on hourly, of the production dispatch and on the exchanges. And after that, we rely on a lot of Monte Carlo years because we use indicators in expectation, for example, or in distribution of our variables to give a robust analysis. Antares Simulator is a tool which is basically being used, for example, at the ENSOI level, which is the European Association of TSOs, in which it's used for European resource adequacy studies and also for European network development studies like the TYNDP. And I put here some major users of Antares, which are mainly utilities, like Elia, the Belgian electricity utility, GRTGaz, the French gas TSO, but we also have academic partners like Mines ParisTech. And I also put an image of the GUI here just to also add something on something we want to keep, which is accessibility. Basically, when Antares Simulator was first designed, its idea was to be able to be used both for academic users, but also for end users like people performing studies, but without having to know everything about what's inside the box. And so we put a lot of effort in developing a clear GUI of the system and on how to configure it. And this is something we want to keep. We really believe in that. Maybe a last presentation point before going to the open source is that we really have a question of performances, which is key in the study that we perform. As I said, we simulate a lot of Monte Carlo years in the studies that we do because we need to perform robust assessments. So to give you an idea, for a standard study on a single simulation, in order to perform a prospective study, like a study at the 2050 horizon, we usually need like 2,000 Monte Carlo years to simulate in order to have robust results. And the second point is that we need to simulate pan-European systems because we need to simulate not only France, which is our primary interest, but also the neighboring countries to have a correct representation of energy exchanges. So computational performance is really a key in order to be able to simulate a lot of scenarios, a lot of variance, a lot of sensitivity analysis to get robust analysis. And for example, for the teams performing studies at RTE in the economic department, to give you a concrete idea, this kind of simulation, for a single simulation, cannot take more than a couple of days for these 2,000 Monte Carlo years. So that's a challenge in terms of performances. So really what we try to get is a balance between getting an optimal result, thanks to a problem which is formulated perfectly, and which gives you realism, and a correct performance, a computation time which is tractable and acceptable for the users. And that's really important for us as well. That's why we need a lot also of optimization competencies in our teams. So the journey to open source in Antares is pretty representative of what we experience at RTE as a whole, basically. Because when we started developing Antares, it was back in 2007, and it was developed internally by RTE users for RTE users. We basically shared Antares with others, like other utilities, European utilities, but it was shared via a proprietary license, so there was a fee which gave you the right to get support from RTE in order to use the tool. But in 2018, we made the choice to release Antares open source under an open source license and to have it free of charge because also we developed a linear solver which is used with the tool, which is open source as well and which is embedded into Antares. But the goals back then was not that much to increase collaboration, but more to increase the transparency of our studies by giving access to the source code so people could analyze the models and could, in that way, have a critical look at our studies and to promote the consistency of our studies. But later on, we realized that it could be very cool to have collaboration on these kind of problems because a lot of you guys are working also on similar topics. And we realized that open sourcing alone, just releasing an existing tool open source, is far from being sufficient to encourage collaboration. And in order to work on that, from last year, what we started to work on are working on two aspects. The first one being the increase of the modularity of our tool. I will talk about that just after that. And trying to encourage open source collaboration with the creation of an open source community about the tool. Regarding the modularity of the tool, the choice that we made, and this is still something we are working on, is to try to decouple things, basically. We had a tool which was initially pretty monolithic, in which the models, so the description of the components, was embedded into the simulator, and the problem definition, for example, the anticipativity that was mentioned earlier, or the time horizon were, let's say, defined as well, hardly in the code. And what we are trying to do right now is to put that out of the model, to have model libraries of components which can be more easily developed and enhanced, and to have a flexible problem definition that people can play with as well, in order to allow flexibility also in the definition of the system and to explore, for example, constraints of different time horizons, different time granularities, constraint of anticipativities, etc., etc. So this is really what we are trying to do right now. I gave you an example, but this is something we are trying to do all over the code to have it more modular, to ease the participation to that code, basically. And on the second aspect, which is collaboration, I can mention the Planetaire project, which Sabera, which is here, who is here, is coordinating. And we also have some PhD students over there working on that. This is a French project which is funded by the French government, as was mentioned by Etienne, which groups industrial partners like GRT Gas and Total Energy and Air Liquide, and an academic partner being Mines Paris-Tech, trying to build this ecosystem of both industrial and academic partners to work on Antares. And the idea is to, let's say, work on real-life demonstrators set up by the industrials in order to improve the models that we use for our studies. And in return, we can perform studies on these new kind of equipments, like thermal storages, for example, using Antares to give industrial users an overview of what can be possible business models, and more generally, how these components will behave in a wider system. So this is really an exchange of expertise that we are proud of. And I can mention as well the Muesli project, which is one of the CRESIM projects that Sébastien mentioned yesterday, which goal is to perform model linking. We talked about that in one of the breakout sessions yesterday, in order to solve adequacy and investment planning studies, relying on what we called, this is a commercial term, smart linking, which is trying to explore new methods for the linking, like the use of machine learning proxies to link with real models instead of the use of full models. So here we are collaborating as well with industrial users and with academic partners from Europe, which are COMIAS, DTU, and TU-Delft, which have expertise in different domains, optimization, multi-energy system modeling, uncertainty representation, etc. And we strongly believe that we need to put all of that together to investigate this topic. So to conclude on Antares, well, this is maybe an illustration of our way to open source on our specific needs that we'd like to address. And the key takeaway is that basically we strongly believe that the reliance on external expertise and external partnerships is crucial in there. That's why, for example, Antares is an example of a tool which was released under the MPL license, which is a weak copyleft license, which allows people basically to take Antares and to embed it in another software and to sell it commercially. But we do that because we really try to improve the quality and transparency of our models. We are not a software editors, so we think that this is the best option to encourage collaboration. And of course, this is also one of the purposes of our presence here. There have been a lot of interesting presentations on the topics that we are interested in, so we are also eager to start further collaboration on the multi-energy adequacy and planning topics. Back to you, Sabah.
And for the following 5 minutes, we will focus on Possible. This is another open source solution. And I was told that you have already a presentation of Possible by RTE, so thanks to them. They promote the same thing, so cool. So PyPossible, it's the Python version of Possible, which is Java framework. And it's with this library, you can change format from another format. For example, from CGMES, standardized format for the description of network, to another format, MATLAB format, for example. And you can perform grid simulation, transient simulation to steady-state simulation for security analysis, for example. So this project is included in the Linux Foundation Energy since 2019, and there are 95 active contributors. And there are a lot of users among students and research institutes, because it's a Python language, so it's more practical. So if you want to play with the Possible libraries, you can do it without installing all the environment in your computer, because you have the access in the GitHub to PyPossible notebooks. So you can scan the QR code if you want to play. And you can launch all these notebooks in the web environment, so everything online with the Binder ecosystem. And it will open Jupyter Lab in your web browser. So I will give you just a free example of notebooks to make it more practical. So we have, for example, the merging of a CGMES file. So you can take the CGMES of Belgium and Netherlands. You get the network diagram here of Belgium, here of Netherlands, and you can merge with just this command. You can merge the two files together. It is useful for security analysis, for example, at a European scale. You can also perform load flow very easily, because you have just to install PyPossible, to import it, to import the network, update the generator production and the loads, and you can perform the load flow, and you obtain 291 megawatt. And if you lose a line, in this example, this line is unavailable, you get 484, it works. So, and you have also another notebook for the dynamic calculation, which is called Dynaflow, which is another tool, but with the possible library, you can call the other tool, and you can perform dynamic simulation. In this example, you will set the high voltage phase shifter in one substation of your network, and you can change the transient. It doesn't work anymore. You can change the time constant of your high voltage phase shifter, and you will see that you will get different values, so it works. So thank you for your attention. As a conclusion, we say that RTE is an industrial company which is promoting open source to achieve energy transition. We have already 10 applications open source. We are developing a growing internal and external ecosystem to do so. And we presented you 2 open source tools. And we hope that it has raised your interest about this community.